So this video is going to finish up 7C. We're on 98. So just when you think it couldn't get any more complicated, of course it can. So look at these interesting examples. So you have a quotient with a negative exponent. So if we go back to our quotient rules, that means you take this numerator and you multiply the ghostly 1, that's the existing, go grab my pen here, the existing exponent. 1 times negative 3 gives you x to the negative 3. And this is also y to the first, and we have to raise him to the negative 3, and here's what you have. But our rule from the last section said, okay, when I have a negative exponent, I can make it positive by taking him, if he's in the numerator, I move him to the denominator. There you go. If he's in the denominator, I move him to the numerator. So this is our answer, but look what we can do without having to do all of this work here. We can go ahead and flip the numerator and the denominator inside the parentheses and change the exponent to a positive exponent and come up with the exact same answer. So here's the same answer. It's worked 2 different ways. Now, I don't know about you, but I would prefer to stick with positive numbers and exponents as much as possible. So the idea is that you do the reciprocal first inside the grouping symbol and then distribute the exponent as a positive exponent. Let's try a couple. All right, so I noticed that I've got a negative exponent with a fraction in the inside. I am going to write the reciprocal of the fraction, and I'm going to make my exponent positive. And then I'm going to go ahead and clean it up. 3 to the 4th power is 81, and 2 to the 4th power, of course, we have memorized, is 16. There's my answer. B, again, notice, negative exponent of a quotient. So we're going to write the reciprocal, y to the 4th, x cubed, and make the exponent a positive 5 instead of negative. That cleans up to y to the 20th over x to the 15th. Last example of this kind, you are going to take the entire numerator and denominator and write the reciprocal. So the b becomes the numerator, and the 3a squared, all of it becomes the denominator raised to the power of positive 3. So that becomes b cubed in the numerator. 3 cubed is 27. A to the 6. 2 times 3 is 6. So that's pretty straightforward once you get the hang of it. There is one more thing that we need to talk about, and that's talking about the exponent of 0. It's legal. You can have an exponent of 0. So here's what it would look like. If you had x to the 3rd divided by x to the 3rd, of course, you should already know that anything divided by himself is 1. But when we have exponents, let's go ahead and do it the way we were taught to do it. So I've got like bases. I have division, so I know I'm going to subtract my exponents. So what happens? 3 minus 3 is 0, x to the 0. But what does that simplify to? X cubed is x times x times x. Same exact thing in the denominator. They all cancel each other out, and oddly enough, your answer is 1. It's not 0. X to the 0 power is 1. Anything to the 0 power is 1, because essentially you're dividing by itself. To get that 0 power, you've got to have like bases, and you have to have the exact same exponents. All right, here's a couple. Anything to the 0 power is 1. Anything raised to the 0 power is 1. And I know that A and B are both raised to the 0 power because they're inside the grouping symbol. Anything to the 0 power is 1. Anything to the 0 power is 1. How about this one? This is interesting. I'm actually also wondering about this one. I have a feeling this answer might be -1. I think it is, because this 5 is the only thing that's raised to the 0 power. So this actually becomes -1. So this is -1. See the difference between C and D? C, the negative sign goes with the 5. So that says -5 is what's raised to the 0 power. D, this negative sign is hanging out as a -1 in front of 5 to the 0 power. So your product here is actually -1. And this one, the 6 is not to the 0 power because, again, he's not in parentheses. So this is 6 times x to the 0 power, which is 6 times 1, which is 6. Okay, have some fun with this. See ya.